In this question, we're asked to find the maximum tension of the string, and we're told that the maximum tension occurs right after the collision. To solve this question, we're going to need to apply Newton's second law and recognize that the block and pellet are moving in circular motion after the collision. The first step is to draw the free body diagram for the system right after the collision. The forces present are gravity and tension. Gravity is acting straight down, and tension is acting up along the direction of the string. The free body diagram therefore looks like gravity pointing in the negative y direction and tension pointing in the positive y direction. We can then write Newton's second law in the y direction. The sum of the forces are therefore tension minus gravity. The mass is the mass of the block plus the mass of the pellet, and the acceleration is the centripetal acceleration, which is equal to the velocity of the block and pellet right after the collision squared divided by the length of the string. We now substitute in the expression for the gravity force, which is the mass of the block plus the mass of the pellet, all times the acceleration due to gravity, and then solve this expression here for the tension. All that's left to do now is to evaluate the expression we just derived for the tension force. We first calculate the velocity of the block and the pellet using the expression we derived in question 2. We plug in the numbers given in the problem statement and evaluate to find that that velocity is 10 meters per second. We then use this number in our expression for tension, along with everything else that we know, and evaluate to find that the maximum tension force is 39.6 newtons.